Hello everyone, welcome to Engineering Explained channel. In this session, I am going to take the basic thermodynamics model 3, lecture 3, that is a heat engine. Heat engine working I am going to discuss in this session, okay, which is the one of the basic energy conversion device where the heat energy is converted into a mechanical energy, and that will be converted by using a engine. That engine is called as a heat engine. And here the how the conversion will be taking place, what are the reservoirs which will interact for the heat engines, we are going to discuss. A heat engine converts thermal energy into mechanical work through a cyclic process governed by the second law of thermodynamics. This cyclic process is governed by second law of thermodynamics. That statement we are going to take after the heat engine and heat pump working explanations. It absorbs heat from a high temperature source and converts part of it into work and rejects the remaining waste heat into to a low temperature sink. Repeating this cycle produces continuous mechanical energy. Here, heat engine receives the heat from the high temperature reservoir and converts part of that heat into a work, and remaining waste heat, which is not to be converted into a work, okay, that will be rejected to a cold reservoir or a low temperature reservoir. Here heat engine necessarily consists of a this heat source and the turbine or a engine, reciprocating engine. There the that working fluid will be uh, acts to convert that heat energy into a mechanical work, the mechanical shaft power we are going to get, and remaining heat will be rejected as heat out. Okay, for that flow of this working fluid in the system, the some pumps or some other systems are used. The further the working we can explain the working principle. In that first one is a heat absorption. The engine's working substance, that is a gas or a liquid, absorbs a quantity of heat. Which amount of heat it will absorbs from a high temperature reservoir, or that is called as a source also. The second one, work output. A part of this absorbed heat is converted into useful mechanical work, often by the expansion of the working substance to a drive, a piston, or a turbine. Third one, heat rejection. The remaining heat, which cannot be converted into work, is rejected as a waste heat, fuel to a low temperature reservoir or sink. Fourth one, cyclic operation. The working substance then return to its initial state and the engine begins the cycle again, allowing for continuous production of mechanical work. Like this, in this sequence, from the heat absorption to the cyclic operation, the total conversion of the heat energy into a mechanical energy, that is a part of the heat energy into the mechanical energy work will be taking place. Further here the key thermodynamic principle what are used in the heat engine we'll discuss. In that first one is the temperature difference. The operation of a heat engine relies on a temperature differential between the hot source and the cold sink. And here what difference is there between the hot source and the cold sink? Depending on that, the what the energy it will convert into a work, that will be depends. First law of thermodynamics. This law states that energy is conserved. The heat absorbed is equal to the work done plus the heat rejected. The work done plus heat rejected. If you add the heat input we are going to get, that input we are going to get, that is the energy is conserved according to the first law of thermodynamics. Second law of thermodynamics. This law sets fundamental limits on the efficiency of heat engines and dictates that 100% conversion of heat to work is impossible. Here it states that 100% we cannot convert heat into work. The some part will be remained as unconverted. Okay, that will be rejected to a sink as a waste heat, and that is stated by second law of thermodynamics. And components, what are there here? High temperature source, which provides the thermal energy to the engine. Working substance, the material like steam or gas, okay, the liquid or gas we are going to use, that undergoes the cyclic processes of absorbing heat, expanding, and doing work. Low temperature sink, the place where the waste heat is expelled. All these are required for the heat engine to be worked. This is about the working of the heat engine. Thanks for watching. If you like, share, subscribe, and comment.